Right, Matrix, what did we do in the previous lesson? We discovered something very powerful. We discovered that if you've got a curve like a parabola, call it f, okay, and you pick a value there, whatever that x is. Remember, we've got a tangent to the curve at that point, whatever it is. Let's call it 3. And remember, f of 3 was the y value that corresponded there, but f prime 3 was the gradient of the tangent to the curve at that point 3, which is the gradient of the tangent, which is the gradient of the curve. And we used a limit formula to be able to determine that. Okay, and this formula f prime x, which you get on a formula sheet now, the limit as h approaches 0 of fx plus h minus fx all over h is called the gradient of the curve, and we use the word first principles. They often in a test will say to you in an exam, determine the gradient of the tangent or the gradient of the curve at 3 using first principles, and we have to then apply this limit formula to be able to do that. Now I'm going to show you a typical exam question, and then we're going to draw the graph of that. Say for example, I said to you fx is equal to negative 2x squared plus 3, which of course is a parabola. It's a sad parabola and has a y-intercept of 3, but don't worry about that for now. We want to find the gradient of the parabola at x equals negative 3, and we want to use first principles. Now let's do this very slowly because it's always a 6 to 8 mark question, which is wonderful in an exam. Now the first thing is we know we've got a formula f prime x is the limit as h approaches 0, fx plus h minus fx over h. Now automatically we've got the fx, so we know what our fx is. We've got it there. Okay, so if we've written it down here, let's write it down again. Fx is equal to negative 2x squared plus 3. That is given to us. We're not going to make that up, they give it to us. What we have to do is add an h to all the x's. Now careful now, this is going to be the f of x plus something. Now watch this, equals negative 2. Now careful, I'm going to keep the negative 2 there. I'm going to open brackets and square and put plus 3. And what I've got, there's my x there. I'm going to, and this is the important thing, I'm going to add an h to that x, and on the right I'm going to add an h to that x, but I keep this in brackets. Okay, the x has been squared, so if you add something to the x, it's still in the bracket squared, and the minus 2 on the outside there. Okay, so what do we then do now? Once we've got that, it's easy. If we simply multiply this out, now careful, if you multiply this product out here, remember it's x squared, then you multiply the x and h and double, so it gives you your 2xh there, and then we square the h, which gives us h squared, and then we've got the plus 3 tagging on. This is pretty much earlier years work. And then multiply the negative 2 in, and what do we have? Negative 2x squared minus 4xh minus 2h squared plus 3. No like terms, so we leave it at that. Now let's go back to our formula. F prime x is the limit as the h approaches 0. Now remember, we're talking about over here fx plus h. Well, what is fx plus h? This is this expression here, so let's put it in. Minus 2x squared minus 4xh minus 2h squared plus 3. That is fx. But now be very careful here, people, because what we're going to do now is we're going to subtract the fx. But the fx is minus 2x squared plus 3. That is the original fx. Be very careful. It's minus that in brackets. And then we divide this by h. So this over here is fx plus h, which we've worked out, and in brackets you've got f of x, and you're subtracting that whole term, that whole expression. So you subtract it and you put it into brackets there. Okay, the rest is now pretty straightforward, because we can say f prime x is equal to the limit as h approaches 0. Have a look at this, negative 2x squared, okay, minus 4xh minus 2h squared plus the 3. Now that minus affects all the signs, so it's plus 2x squared, and we subtract 3. And all of this mess is divided by h. Okay, so what is f prime x going to equal? It's the limit as h approaches 0. Okay, there we go. And notice that these guys cancel here. The 2x squareds cancel, the 3's cancel, and we left with, over here, we left with negative 4xh minus 2h squared, all divided by h. Now from limits, of course, you can't plug in 0 now, but what we can do is we can factorize, as we did previously in limits. Okay, so we take out the h. I'm not going to worry about taking out negative 2. Just simply take out the h, and you'll be left with minus 4x minus 2h all over h. Some people might want to take out the negative 2 as a common factor. That's fine, but we just want to get rid of the h's, so just simply take out the h. And then what do we have? F prime x is the limit as h approaches 0. The h's cancel, and you left with negative 4x minus 2h. Fractions are gone, no problem, and h approaches 0, so that's negative 4x minus 2 multiplied by 0 there, which is where h is going to. So your gradient of your tangent, or your gradient of your curve at that point, is going to, at any point on the curve, is negative 4x. So if you want to get the gradient at negative 3 now, all you do is you plug that into this expression, and we get a gradient of 12, which is great. But what does this all mean if we have a look at it? And I think it'll be good to actually draw the graph of the parabola. Now don't panic with this. What I'm going to show you is, if you've got your parabola quickly here, I'm just going to draw it quickly. Now don't worry about sketching this. It kind of does this. Cuts the y-axis at 3 and then comes down like this. It's a sad chappy. Okay. Now this is your graph of f. Okay, which is equal to, in fact, it's negative 2x squared plus 3. Good. Okay. Now, if you take at negative 3, if we go to negative 3, which would be somewhere there, you can get the corresponding y value, but you could also get the gradient of the tangent to the curve at that point. The tangent, the gradient of the curve, or the gradient of the tangent. Now, what is the y value corresponding there? Just a matter of interest. If you have your y value, the f of negative 3 is the y value, would be negative 2 times negative 3 squared plus 3, which is negative 2 times 9 plus 3. Okay, that's negative 18 plus 3 is negative 15. This is not to scale, by the way, negative 15. So the point on the curve, that point is x is negative 3, y is negative 15. But what is the gradient of the tangent? The gradient of the tangent is going to be 12. Okay, it's the gradient of the parabola at that point, negative 3. It's the gradient of the line. Remember the line y equals mx plus c? The m is the gradient. That is the gradient of that blue line. And the line is sloping to the right, so the gradient is positive. It's y equals 12x plus something, whatever that y-intercept is. So that's at x equals minus 3, the gradient of the tangent is going to be 12. But the y value is negative 15 corresponding to that. So this is f minus 3, but what is f prime negative 3 is 12. That's the gradient of the tangent, or the gradient of the curve at that point at x equals minus 3. And also, if you think about it, if you take any old parabola, so say we're using the one that we chose here, this guy, do you notice something very interesting? If you're at negative 3, you've got a tangent, its gradient is positive, and you'll notice that the parabola is increasing, the gradient is positive. When we get to the turning point there, the gradient is 0. The tangent line has a gradient of 0, and the graph is almost stationary. It's not moving. It goes up, and then it's neither increasing nor decreasing. And then if we move on, we can see that the gradient of the tangent is negative. We're going to do a lot of this when we do cubic graphs and that, so don't worry about that. But you can see that the tangents, their gradients change as you move from left to right. The graph increases or it decreases depending on where you are. You never have a fixed gradient anywhere. The gradient of the tangent line changes as you move from left to right, as you increase and decrease. But remember, f prime is the gradient, and fx is the y value corresponding. Let's just do one more quickly just to confirm that you've got it. If you have a look at this, something quite interesting. If I said to you, what is the gradient of this line, y equals 3x? Well, you know the gradient is 3. But watch this. If you work out, if you add an h to the x's, have a look at this. If you add an h to the x's, what do we get? We get 3x plus 3h. Now, if we work out the gradient of this line using first principles and using this formula, let me show you something brilliant that happens here. If we just write our formula down and we do that, have a look at this. This is the limit as h approaches 0. F of x plus h is 3x plus 3h. Subtract the fx, which is 3x divided by h. Now watch this. This is brilliant. This equals the limit as h approaches 0. The 3x's cancel, and you're left with 3h over h. And the h's cancel. Now look at this from limits. You're going to get that as 3. And this is 3. Now, isn't that interesting? That's the gradient of that line 3. So first principles works as well.